Hi guys, welcome to Abby B Vlog. Our today's episode is about Fibonacci Sequence. By the way, this is Teacher Abe, your lecturer for today. To start with, let's have the learning objectives. Number 1, to discuss the concept of Fibonacci and its application. To identify the patterns in nature and regularities in the world. And lastly, to appreciate the nature and the uses of mathematics in everyday life. Now, let's go over to the definition of Fibonacci. Fibonacci Sequence. Fibonacci Sequence is the series of numbers 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, and so on and so forth. The next number is found by adding up the two numbers before it. 2 is found by adding the two numbers before it, which are 1 plus 1. The 3 is found by adding the two numbers before it, 1 plus 2. Then 5 is found by adding the two numbers before it, 2 plus 3. We got 8 because of adding 3 plus 5. Then we can have 13 by adding up 5 plus 8. And so on and so forth. There's another definition of Fibonacci sequence. It is a series of numbers in which each number is the sum of the two preceding numbers. It is a sequence f sub 1, f sub 2, f sub 3, f sub 4 until f sub n. F sub n which has its two term f sub 1 and f sub 2 both equal to 1 and satisfies thereafter the recursion formula such as f sub n is equal to f sub 1 plus f sub 2. Now let's have an example. The rabbit habit. On the first column we have the months, 1 to 5 months. Then we have the figure of rabbit, the solid figure. Then on the third column we have the number of pairs or paired rabbit. As you can see, on the first column, we have the first month. And then the solid figure on the first month, we have 2 rabbit or 1 paired rabbit. So that's why the third column is 1. For the second month, we still have 2 rabbit or 1 paired rabbit. So that's why we have 1 in the third column. For the third month, we have 4 rabbit already. So, we have 2 paired rabbit on the third column. For the fourth month, we have 6 rabbit. So, that's why we have 3 paired rabbit. For the fifth month, we have 10 rabbits. So, how many paired rabbit do we have? We have 5 paired rabbit. So, in this case, what have you noticed with our column number 3 or column 3? That is correct. We have Fibonacci sequence. If we have a Fibonacci sequence on this table, what would be our numbered paired rabbit on the 6 months? If your answer is 8, then you got the correct answer. Now let's have another table. So this time, this is much bigger. It is, or the month is on 12 months. We have adult paired on the second column. On the third column, we have young pairs and then the total. So the total would be the sum of adult pair and young pairs. On the first month, we have 1 adult pair and 1 young pair. So that's why the total is 2. Then, on the second column or second row, we have second month, and then 2 adult pair, and then 1 young pair. So we add it, then we have 3. For the third month, we have 3 adult pair and 2 young paired rabbit. So the total is 5. For the fourth month, we have 5 adult paired rabbit and 3 adult paired rabbit. So we got the total of 8. So as you can see, that is already on Fibonacci sequence. The column 2, 3, and 4 is already on Fibonacci sequence. But of course, it is different from each respective month. As you can see on the third column, the young paired rabbit is the one who have a perfect Fibonacci sequence because it started from 1, followed by 1. Example of Fibonacci sequence are flower petals, spiral on sunflower seeds, spiral on pineapples, pine cones. Golden ratio is also known as the divine proportion. This contains the drawing of the 5 platonic solids, and it was probably Da Vinci who first called it the section aurea. It is a Latin word which means golden section. Golden ratio is the relationship between numbers on the Fibonacci sequence, where plotting the relationship on scales results in a spiral shape. And you know guys, there is a formula for the golden ratio, and it was derived from a line segment A and line segment B. The formula for this is A plus B over A equal to A over B. Then they got the value for the golden ratio, which is 1.618034. Aside from the golden ratio, they also have golden rectangle. It is known as one of the most visually satisfying of geometric forms. It is also related to the golden spirals. The spirals is drawn starting from the inner 1 by 1 square and continues outwards to successively larger squares. As you can see on the figure, we start from 1, followed by another 1. So we have 1, 1, then 1, 1, 2, then 1, 1, 2, 3, then 1, 1, 2, 3, 5, then 1, 1, 2, 3, 5, 8, and so on and so forth. So this is the representation of the golden rectangle. So in your home, you can do this simple activity. So when we make a square with other widths, get a nice spiral. Do you see how the squares fit neatly together? For example, 5 and 8 make 13. 8 and 13 make 21, and so on. And here is the surprise. When we take any two successive Fibonacci numbers, the ratio is very close to the golden ratio, the pi, which is approximately 1.61803, and so on and so forth. In fact, the bigger the pair of Fibonacci numbers, the closer the approximation. Let us try a few. We have here column A, column B, and column B slash A. On column A, we have 2, 3, 5, 8, and so on and so forth until it reaches 144, and 233, and so on and so forth. For column B, we have 3, 5, 8, 13 until it reached 233, and then 377, and so on and so forth. For column number 3, we divide B to A. That's why we have 1.5 in 3 divided by 2. Then we got 1.6666666 by 5 divided by 3. Then we have 8 divided by 5, 1.6. And then 13 divided by 8, we have 1.625. Then for 233 divided by 144, we have 1.618055556. Then, if we divide 377 to 233, we got 1.618025751. If you're going to notice, the value of B divided by A is very close to golden ratio as the bigger values arises. Now, let's go to golden ratio in nature. Do you know that the leaf arrangement in plants to the structures in outer space elicit golden ratio? Remarkable proportion of growth pattern in living things like plants and animals. The position and propositions of the key dimensions of many animals are based on pi. Now let's have an example of golden ratio in nature. We have horn of rump. The wing dimension and location of eye-like spots on moth. Body sections of ants and other insects. Body features of animals like tiger, fish, penguin, dolphin, and etc. Spirals of seashells. Growth pattern on branches of tree. Human face and DNA proportion. Now let's go to golden ratio in arts. In 1900s, Pejas or pi was proposed by mathematician Mark Barr for golden ratio. Pejas used golden ratio to his sculpture. Example of his famous work was the exterior dimension of Parthenon. Timaeus. Plato described 5 possible regular solids that relate to the golden ratio. Platonic solids are tetrahedron, cube, octahedron, icosahedron, dodecahedron. Euclid gave the definition of the golden ratio. He said that golden ratio is a dividing line in the extreme and mean ratio in his book Elements. He proved the link of number to the construction of the pentagram. Each intersection of the edges sections to other edge of the pentagram is golden ratio. Also, the ratio of the length of the shorter segment to the segment bound by the two intersecting lines is a golden ratio. And now let's go to the work of Leonardo da Vinci. Actually, he incorporated the golden ratio in his paintings. His paintings are Vitruvian Man, The Last Supper, Mona Lisa, St. Jude in the Wilderness. Now, let's have Michelangelo. His real name is Michelangelo di Lodovico Simon. He is the greatest living artist in his time. He used golden ratio in meeting of God's finger and Adam's finger. His paintings are The Creation of Adam, Holy Family. Of course, we also have Raphael. His name is Rafael Sancho da Urbino. His paintings are The School of Athens and Crucifixion. Sandro Botticelli. His real name is Alessandro di Mariano di Bani Filipepi. He is an Italian painter in an early Renaissance. He is also the greatest living artist in his time. Birth of Venus, her navel, is also golden ratio, point of the height of the Venus body. Sandro Botticelli's paintings are The Birth of Venus. Most of his painting can be found in Uffizi Gallery in Florence, Italy. Another artist is Georges-Pierre Seurat. He was a French post-impressionist painter. His paintings are Paters and Asineres, Bridge of Corby Boy, Sunday on La Grande Hate. So these are the paintings of George Pierre Seurat. And we have Salvador Dali. His real name is Salvador Domingo Felipe Jacinto Dali. He has also a painting with golden ratio. His painting is the Sacrament of the Last Supper. Now let's go to golden ratio in architecture. Some of the architectural structure with golden ratio are Great Pyramid, Notre Dame, Taj Mahal, Cartes Cathedral, United Nations Building, Eiffel Tower, CN Tower, and others. Now let's start discussing the Great Pyramid of Giza. The Great Pyramid of Giza, built in 4700s BC in Ames Papyrus of Egypt. The pyramid used golden ratio with a length of 756 feet and a height of 481 feet. The ratio of the base to the height is 1.5717. Next is the Notre Dame. Notre Dame is a Gothic cathedral in Paris, which is built between 1163 and 1250. It appears to have golden ratio in numbers of its key proportion of design. Next is the Taj Mahal. Taj Mahal is in India. It is used golden ratio in its construction and was completed in 1648. The order and proportion of the arches is with thirds of golden ratio. Chartres Cathedral also exhibit golden ratio. It's just like with the Notre Dame. Next, we have United Nations Building. The United Nations Building have a golden proportion. It is configured in the window. Then we also have the Eiffel Tower. It is located in Paris, France. It was named after the Alexander Gustave Eiffel, who designed and built the tower. And next is the CN Tower, located in Toronto, Canada. It is the tallest tower and freestanding structure in the world. Contains golden ratio design. The ratio of the observation deck at 342 meters to the total height of 553.33 is 0.61 or pi, the reciprocal of pi. So that's why it is also under the golden ratio. Okay? That's all for today, guys. Please study set theory and the different types of sets. That would be our next discussion, and be ready for a short quiz. Thank you for watching. Please don't forget to subscribe and share our video. Thank you. Bye-bye.